Hello for everyone, welcome to my YouTube channel. As you know that I'm not posting videos since 1 month, and there is a reason. I had exams in 1 month. That's why starting from today I will post one paper two paper per week. Okay, now we will discuss the chemistry paper Monday 11 January 2021, Pearson Edexcel GCSE 9-1, and Unit 4 CH1 Science Double Award for SDO Paper1CR. Okay, let's start. The first question. The box lists some substance. We can see substance from the box: air, bromine, carbon, copper, glucose, nitrogen, oxygen, sulfur, and water. Okay, choose substance from the box to answer these questions. Each substance may be used once, more than once, or not at all. Okay, the first question: name a metallic element. There's only one metallic element, and it is copper. The next one: name a compound. Name a compound. Okay, air is not compound, it's mixture. Bromine is not, carbon is not, copper is not. Glucose, it is the compound made by carbon, hydrogen, and oxygen atoms, like the formula of C6, H12, and O6. And nitrogen, it's not. Oxygen, not. Sulfur is not. And water, it's compound, it's chemically bonded. It's made by covalent bond of hydrogen and oxygen. That's why we can write glucose, neither water. Okay, the next question: name a mixture. As I said, there is one mixture, and it's air, because it made up different type of gases. Name an element that is a gas at room temperature. Bromine is liquid form, carbon is not, copper is metal, and nitrogen. We can say nitrogen. Nitrogen is in gas form in room temperature, and oxygen also. Next question: name an element that forms a basic oxide. We know that group 1 and group 2 and some of the transition metals make base oxides, and one of these is copper. Name two elements that are in the same group of the periodic table. Okay, you will see oxygen and sulfur, they are in group 6, and it means that it is the answer for this question: oxygen and sulfur. The next question, second part. A student does a chromatography experiment using ink 1, ink 2, and 3 known dyes A, B, and C. The student uses water as a solvent. The diagram shows the student's chromatogram. Okay, you can see he tested 2 types of ink and 3 types of dye. Okay, that is, what conclusions can be made about the composition of ink 1? Okay, composition of ink 1. Here, as we can see, it made one spot here, one here, and another one here. Okay, and by the way, we can see that the dye 1 contains A, like dye A contains ink 1, and we can write that dye ink 1 contains dye A. And next one is the same, it made the same spot as dye B. It means that ink 1 also contains dye B. And as we can see, it doesn't contains dye C. Okay, give one conclusion that can be made about ink 2. We can make a conclusion that we can make two conclusions. The first one is ink 2 is insoluble in the solvent, or we can say that ink 2 doesn't contain dye A or B or C. Both of the answers are correct. Next part. Suggest how the student could change the experiment to find the composition of ink 2. The student should or repeat the experiment using different solvents, because if ink 2 do not is insoluble in this type of solvent that student use first, like the solvent that student use firstly may be insoluble for the ink 2. That's why the student should use different solvent. Calculate RF value of the dye C, giving your answer to significant figures. Okay, we can note the answer if we can print this paper and we should do calculation like distance moved by spot out of distance moved by solvent front, and I think the answer will be around 5.4, 5.6 or 7.9 to 8.1, but the expected result will be 0.69. The third one. Crude oil is a mixture of organic compounds. Most of the compounds are members of the same homologous series. State the name of this homologous series. Okay. We know that most crude oil contains homologous series called alkanes. Okay. An industrial process is used to separate crude oil into fractions. The process depends on a property of the fractions. What is the property? The property is boiling point, because the crude oil need to be vaporized to separate the organic compounds from it. That's why the answer is boiling point. And next one, the boxes give some uses of fractions and some names of fractions. There are one straight line from each used to its correct fraction. Okay, fuel for airplanes. As we know that we use kerosene as a fuel for airplanes. And next one, fuel for ships. We usually use fuel oil, and for surfacing roads we use the most dense one, and it is bitumen. Fuels obtained from the fractions may contain impurities. Explain how the combustion of a common impurity in fuels may cause an environmental problem. Okay. There may be sulfur in the crude oil, while the cars using fuel, and when sulfur burns, it forms sulfur oxide, and this sulfur oxide goes to the atmosphere of Earth and react with water. After reaction, it forms sulfuric acid. And it causes acidic rain, which damages the forests and can be like and can cause habitat loss. Okay, the next one. Some of the fractions contain long chain molecules which are not very useful. Give the name of the process used to convert long chain molecules into more useful shorter ones. We say this as a cracking process. Give the catalyst and temperature used in the industrial process to convert a long chain molecules into shorter chain molecules. We use catalyst alumina or silica, and the temperature should be around 600 to 700 Celsius. When C13H28 is used, this process, the different molecules are formed. Complete the equation for the reaction. When this molecule is cracked, they will be made pentene and ethene. They are both alkenes which used for polymerization. And fourth section. When iron is left in damp air, rust forms on its surface. State the chemical name for rust. We call rust like chemical name for rust, and it is iron 3 oxide. And explain how a barrier method prevent rusting. Barrier method involves coating iron in paint, and it stops oxygen getting into the iron, or prevents oxygen reacting with iron. Okay, the next question. A student used this apparatus to find the approximate percentage by volume of oxygen in air. Okay, the student's method: place a graduated glass tube in a beaker of water, place some damp iron wool and a rubber band in the top of the tube, record the reading of the water level in the test tube, leaving the apparatus for a few days, record the reading of the water level again. Okay, the diagram shows the readings at the start and at the end of the experiment. Okay, use the readings to complete the table, giving all values to the nearest 0.5 centimeter cube. Okay, reading at start in centimeter cube is 20.5, as you can see from here, the starting position, and reading at the end is around 33.5. Volume of oxygen used in centimeter cube is the result of subtracting 20.5 from 33.5, and that is 13.0. Okay. The student used these results to calculate the percentage by volume of oxygen in air. Suggest why her calculated value is lower than expected result. Maybe not all of oxygen particles had reacted, or there wasn't enough iron wool to react. And the C1. The student repeats the experiment using the same apparatus. These are her results for the second experiment. Okay, volume of air in test tube at start 80.0 centimeter cube, reading at start 20.0 centimeter cube, or 20.0, reading at the end 35.5. Use results to calculate the percentage by volume of oxygen in air. Okay, for this we should subtract the final result from initial one. No, initial result from final one. 35.5 minus 20.0 is equals to 15.5. And for finding the percentage of the oxygen in air, we should divide 15.5 to 80, which is the volume of air in the tube at start, and we will multiply it 100 for making it in percentage. It is 90.4. Okay, the fifth question. A student used this apparatus to investigate the effect on heat on different solid metal carbonates. Okay, this is the student's method. Use a spatula to put some metal carbonate in the boiling tube. Fit the delivery tube into position. Pour some lime water into the test tube. Start the timer and immediately begin to heat the metal carbonate. Record the time when a change first occurs in the lime water. Okay. The student repeats the method using different metal carbonates. When a metal carbonate is heated, a reaction sometimes occurs. The equation for the reaction is metal carbonate will be metal oxide plus carbon dioxide. State the name given to this type of reaction. There is producing two or more than two products for one reactor. That's why we call it thermal decomposition, or we can say only decomposition 2. Okay. State two variables that the student should control this investigation. He should use same amount of metal carbonate, because if he use like different mass or different size of metal carbonates, the experiment may be like inferior, like it can't be fair. And he should use same volume of lime water, because if he use more amount of or higher volume of lime water, it takes more time to change its color. Suggest why bubbles appear in the lime water immediately after heating has started, but before there is any change to metal carbonate. Because bubbles are air from tube, like caused by air, like air's temperature increase. That's why the bubbles made. Okay, appear the purpose of lime water in this investigation. Okay, if the lime water turns into milky color or milky solution, it means that there is produced carbon dioxide, and it shows metal carbonate has reacted or decomposed. The table shows some of the results for the student's investigation. State the color change that occurs for copper carbonate. Okay, copper carbonate turns black from green, like green to black. Give a chemical equation for this reaction of copper to carbonate. Okay, copper carbonate will be copper oxide 2C plus CO2 or carbon dioxide. There's a relationship between the position of a metal in the reactivity series, how easily the metal carbonate reacts when heated. Use the student's results and your own knowledge to deduce this relationship. Okay. As lower the metal in reactivity metal in reactivity series, more easily the metal carbonate reacts or decomposes. State how you should expand the investigation to see if your deduction is correct. Okay, this like repeating the experiment with using different types of metal carbonates. Zinc reacts with dilute hydrochloric acid to form oxygen. Give the chemical equation for this. Okay, zinc plus 2 HCl is produced zinc chloride plus hydrogen gas. Give a test for hydrogen gas, and it is lighted split, and it produces squeaky pop. A student investigates the reaction between piece of zinc and dilute hydrochloric acid. In each experiment, he used the same mass of zinc but a different volume of the acid. He collects the hydrogen and measures its volumes in each experiment. The graph shows the results of students. Use the graph to find the maximum volume of acid needed to react with all of the zinc. Okay? Here is the volume of acid, and we'll go lower. And it is 52 centimeter cube. The student repeats the investigation using hydrochloric acid of double the original concentration. Determine the volume of oxygen that would be collected using 15 centimeter cube of this acid. Show your working on the graph. Okay, first we should put a vertical from 15 centimeter cube of acid to the graph. It will go here around 34 centimeter cube, and volume hydrogen from graph multiplied by 2, like it is 34, and if you multiply it for 2 it will be 68. And the final answer is 68. Next one. Explain how increasing the concentration of hydrochloric acid affects the rate of reaction. Okay, if we increase the concentration of hydrochloric acid, more acid particles have in the same volume, and it means that more successful collisions per second. If there is more successful collisions, the rate of reaction increases. Okay, the D1. The rate of reaction could also be affected by changing the temperature of hydrochloric acid or by using a catalyst. Explain one other way in which the rate of reaction between zinc and hydrochloric acid can be affected. The surface area. Because increasing surface area of zinc by cutting or using smaller pieces of zinc made more successful collisions per second and collision per second and rate of reaction increases. Okay, the seventh question. The formation of ions and covalent bonds involve electrons. The table gives the electronic configurations of atoms of hydrogen and lithium and fluorine. Okay, the hydrogen element's electronic configuration is 1, the lithium is 2, 1, and the fluorine is 2, 8, 7. Describe the different roles of electrons in the formation of ions in lithium chloride, covalent bonds in hydrogen fluoride. Okay. Lithium atom loses electrons and fluorine atom gaining an electron or gain electron, while formation of covalent bonds in hydrogen while formation of lithium chloride and while like chlorine and hydrogen and fluorine atoms share their pair of electrons, covalent bond made. Explain why lithium has a higher melting point than hydrogen fluoride. Refer to the structure and bonding in your answer. Okay. Lithium chloride is giant ionic structure. It have strong electrostatic forces of attraction between oppositely charged ions. And hydrogen fluoride have simple molecular structure. It have weak intermolecular forces of attraction, and the main reason is more heat energy required to break a bond between lithium and fluoride ions. Okay, eighth question. Organic compounds can exist as isomers. Explain what is meant by isomers. Okay, molecules having same molecular formula but different structural or displayed formula. Okay, draw compound D. A compound Q reacts with bromine with the presence of ultraviolet radiation to form the compound C4H8Br2. Draw the display formula of isomer. Okay, isomer of Q. Okay, we'll draw them. The first one should be like that. C H here, double bond, one hydrogen atom to here, carbon, and one another carbon. Two hydrogen atoms here and three right there. And this. And for the second structure we'll draw like that. Double bond and one of this here, three hydrogen here, one hydrogen to here, one hydrogen to here, and three for here. And it's done. The acrylic polymer can be formed from molecules with this structure. A student describes the molecule as an unsaturated hydrocarbon and explain whether this is a correct description. Okay, yeah, it is unsaturated hydrocarbon because molecule is unsaturated as contains double bond between carbon atoms, and molecule not a hydrocarbon as contains oxygen, as it contains oxygen. Complete the equation for the polymerization reaction. Okay, there was one question. Name the type of polymerization that occurs in the formation of the polymer, and it's called addition polymerization. Okay, complete the equation of polymerization. Okay. That and for here. Okay. Octane is a compound in petrol. The equation for the complete combustion of octane is here. We can see from the diagram. C8H18 plus 12.5 O2 molecules will be 8 CO2 plus 9 H2O. The fuel tank of a car contains 50 decimeter cube of octane. Calculate the mass in kilogram of carbon dioxide formed if all the octane in the fuel tank undergoes complete combustion. Okay, for finding this one, firstly we should multiply 50 to 700, and it is 35,000 grams, and we will find the mass of C8H18, and it is 114, and CO2 and the mass of CO2 is equals to 44 per mole, 44 grams per mole, and we will multiply 8 to 44, and answer will be 352 grams. Then we will multiply 35,000 to 352 and divide it to 114, and the answer is 108,000 70.2 gram of CO2, and it will be around 108 kilogram. The next question: is an environmental problem caused by carbon dioxide, and it is global warming. Most of students makes write incorrect answer here. Most of them write like greenhouse effect, but it's not correct because carbon dioxide is not is not greenhouse gas. Okay, please learn it. Nice question. Lithium, sodium, and potassium are the first three elements in group 1 of periodic table. Suggest why reason these three elements are all stored in paraffin oil. Because of prevent them or keep them from contacting with air, because they can react with air too fast. Cesium is below potassium in group 1. Give a similarity or a difference between the reactions of potassium with water and cesium with water. Okay, the similarity is both of them fizz and move on the surface of water, and the difference is cesium reacts faster. Get the chemical calculation for the reaction between cesium and water. Okay, 2 cesium plus 2 H2O, and they will produce 2 cesium oxide plus hydrogen. The next one: a student investigates the temperature change in the reaction between dilute acids and solutions of group 1 hydroxides. He uses this apparatus. Okay, this is student's method. Measure the temperature of 50 cm³ of hydrochloric acid. Pour the acid into a polystyrene cup. Add 50 cm³ of sodium hydroxide solution to the acid. Measure the maximum temperature of the mixture. Suggest what could be added to the apparatus to improve the experiment. They should cover the apparatus. Okay, the next one: The next question is explain a change to the method that would improve the accuracy of the experiment. Like they should stir solution to obtain more accurate result, more accurate temperature. Okay, there are the students' results. Temperature of hydrochloric acid 90.9 Celsius. Maximum temperature of mixture 26.5. Calculate the energy Q in joules of this reaction. Okay, we have a formula like Q equals to MC delta T. Means that the mass is around 6.6 and specific heat capacity is 4.2 multiplied by 4.2 and multiplied by temperature change. The 6.6 is the temperature change and 4.2 is specific heat capacity, and the mass of this is 100, and the answer will be 200 or 2800 or 2800 joules. Next one, in the student's reaction between hydrochloric acid and sodium hydroxide, 0.050 mole of water forms. Calculate the molar enthalpy change in kilojoule per mole for this reaction. For finding it, firstly we should divide 2800 to 0.05, and that is 56,000, and if you convert it to kilojoule it will be 56, and enthalpy change it will be minus 56. This question is about salts. Soluble salt can be prepared by reacting between a metal oxide of an acid. The equation for this type of reaction is metal oxide plus acid will be salt plus water. State the name given to this type of reaction. The acid and oxide, or like alkaline reacting and salt water producing H plus hydrogen ion plus a hydroxide ion, it will be produce water. That's why it's called neutralization reaction. Say in terms of protons, what happened in this reaction? Acid donates proton and base accepts proton. Or we can say base accepts proton. A student is given 50 cm cube of dilute sulfuric acid and a bottle of solid copper 2 carbonate. Describe the method that the student should use to prepare a saturated solution of copper 2 sulfate. If you're in your answer, refer to the pieces of apparatus that the student should use. Okay, there is appropriate use of at least 3 named pieces of apparatus, and add copper to carbonate to dilute sulfuric acid until no more effect if for skin. Filter it and heat the filtrate until crystals start to appear. Filter to obtain the saturated solution. Okay. The student produces dry of crystals of hydrated copper to sulfate from the saturated solution. He calculates that 6.40 of dry crystals should be formed. The mass of crystals he actually obtained is 1.8 less than he calculated. Calculate the student's percentage yield. Give your answer to one decimal place. Okay, we will subtract 108 from 6.4. It's equals to 4.6, and 4.6 out of 6.4, and for finding in percentage we multiply it 100, and the result is 71.9. Okay, gypsum is hydrated calcium sulfate. A sample of gypsum contains 79% of calcium sulfate by mass. Calculate the value of X in case in calcium sulfate and X number of like water. For finding this, as we know that if the calcium sulfate is 79% of mass by mass, and the water should be 21, and we will divide 79 to 136, which is the mass of the calcium sulfate, and it is 0.18. If we divide 21 to 18, it is 1.17 and 1.17. And like we will divide like 1.17, and then like we will take 0.58 and divide it 0.58, because we like in ratio we will put like it is 1, and we will divide 1.17 to 0.58, and it is 2. As we can see that X is equals to 2 from ratio, like calcium sulfate to water ratio is equals to 1 to 2, and X equals to 2. Describe a test for calcium ions in the sample of gypsum. We should do flame test, and there should like appear orange red flame. And I saying it's the end of the paper. Thank you for attention. Please subscribe for my YouTube channel and like for the video. Thank you.